Welcome to Data Dawg. I am Data, and I am your dog. In this video, we're going to tackle variance and standard deviation. In our previous videos, we spoke about how we used methods of central tendencies such as mean and median to summarize our data. That is one important factor in learning about our data. However, it's also important to learn about how much the data can vary or change. Going back to the shoe size data we used in the last video, we learned that the average was 9. But that doesn't tell us the whole picture. Sure, the 7 and the 9 and the 10 are pretty close, but what about the 3 or the 20? Those are the outliers that we had from the data. Now, if I was starting a real company, I wouldn't want to just make size 9 shoes. I would also want to make other similarly sized shoes as well so others can wear them. In order to know how many different sizes to make, I would need to know about the variance. Luckily, we do have a formula for variance. In fact, we have two. We have the population parameter and the sample statistic. But as we mentioned in previous videos, trying to pull the entire population is incredibly arduous. So we will stick to the one for sample. We do this because statistics almost always focuses on sample data. If this looks confusing, don't sweat it. We'll work at this step by step. The first thing we do is make a table out of the data that we have. In the first column, we will list out all the values. On each row in the second column, we will print out our mean, which is 9. Great! Now let's add a third column. And in this third column, we will simply subtract the value from the mean on each row. Now after that, we will add a fourth column. What we do in the fourth column is we square the number that is on the third column. Great! Now remember that weird looking E in the formula? Well, that's a Greek letter called sigma, and all that it means is that we just simply add up all the numbers from the last column. That adds up to 178. That's the top part of the formula. So our formula is now 178 over n minus 1. N is the number of values that we have, the count of our sample, which is 6. So as we all know, 6 minus 1 is 5. So the formula is 178 over 5. Now this might be where we need a calculator, which is okay. After dividing 178 by 5, we find that the answer is 35.6. That's our variance. This is fantastic. Something you should know is that when we measure a spread, variance isn't what's used. We use standard deviation, and the reason why we use that is because it can be more easily used for other tests such as comparing different groups and finding out more information. Now you might be thinking, great, more math. But if you've gotten this far, you're already almost done. Finding the standard deviation from the variance is easy. All you have to do is just find the square root of the number. You might need a calculator, and again, that's totally okay. After rounding the number to the last few decimal points, it comes out to 5.968. This is a very big standard deviation. And the reason why is because of the outliers that we have. To see this in perspective, if we were to remove the 3 and the 20 from our dataset, our standard deviation drops to just around 2.236. The biggest factor of what determines if you have a large standard deviation or not comes from that third column, where we found out how far each data point was from the mean. The farther that number is from 0, the larger your standard deviation. As you probably know, even negative numbers become positive once you square it. Congratulations! You now know how to find out the spread of a dataset by calculating variance and standard deviation. Stick around as we explore the wonders of data together here on Data Dawg. Don't forget to join our pack by pawing that like button, subscribing, ringing that bell notification icon so you will not miss a future video, leaving a comment, and sharing this video with the rest of your pups. So until next time, stay curious, stay analytical. Peace out, dogs.